Hello, everyone. Welcome to this evening's edition of the ChiPy main meeting. We have a very special edition this time for you guys. It's the annual Python-powered business event. We have some really great speakers today. I'll be getting to those individuals shortly. But first, just to do a little bookkeeping here, we're going to go through our standard kind of ChiPy layout. Just to introduce ChiPy and make sure everybody knows who we are, what we do. So again, welcome to this evening's edition of the main meeting, which is a special edition of Python-powered business. I'd like to give a quick thanks to our sponsors, jFrog, Braintree, and Zoro. They provide a lot of funding for us to make these type of things happen and keep our website running. And when we do go back to live events, getting everybody a slice of pizza at these events. jFrog is one of our good sponsors again. They are sponsor a raffle for us every month. This month we have 3 Adafruit glues that are being raffled off. They are CircuitPython compatible. You can scan the QR code to enter, or you can click on the link that will be dropped in the live chat. The winner will be selected in 2 business days from this event, and then the winner will be shared on our meetup page and congratulated on social media. I will post this a couple times throughout the meeting just so everybody is aware. ChiPy does have a code of conduct. If you're interested in what that is specifically, please click on this link, the chipy.org pages/conduct. Basically, just we ask everybody to behave in a professional manner. What is ChiPy? ChiPy is a Python-focused community that was started in 2003. Our board members are myself, Aaron Elmquist is the secretary, Chris Ludite, Heather White, Joe Janisic, our treasurer, Kevin Nislato, and Zach Rosenberg, our chair. We have several initiatives with ChiPy, one of those being the Project Night and Web Guild, which will be held next week, buddy mentorship program at chipymentor.org. We have a website set up where if you want to mentor people in Python or get some mentorship, we'll try to match people up on that site by their skill levels and what you're looking to learn. There's the Python lunch break. There's an algo sig, and then we do have a job board on chipy.org. There's several postings on there right now if you're interested and looking for a job. If you want to post on chipy.org, please do. Pretty straightforward. Upcoming events, again, Virtual Project Night will be Thursday, November 18th. Algo sig is happening on December 2nd. That's going to be Advent of Code edition. And then the next main meeting will be on Thursday, December 9th. If you need to reach out to ChiPy, you can find us on Slack, Twitter, or chipy.org on the contact page. Tonight's schedule, we have 5 really great speakers lined up for you to talk about their businesses and how they use Python to power their business. We have Daniel Keeler from jFrog, Joe Nylon from Zoro, Patrick Fuller from NuMat Industries, Santiago Santana from Narrative Science, and Jordan Bettis from Nielsen. At the end of each talk, the speakers have graciously agreed to do a Q&A. Please just type your questions into the YouTube live stream. Please be aware between what we're posting and what you're seeing, there is about a 10-second delay in that. We'll try to eliminate the dead air as much as possible. And then after all the speeches are concluded, we will have an after party at chipy.town if you're interested in walking around in a virtual space and maybe meeting some of the speakers and your fellow ChiPy community members. And with that, I think we're going to go into our first speech, our first topic with Daniel from jFrog. Hi, Daniel. Welcome.
Hi, thank you. Thank you, Aaron. Thank you very much. How are you guys? So I'm Daniel from jFrog, automation lead. I'm using Python for the last 9 years. Um, Here's my email, my GitHub account. Feel free to reach me out for questions or anything. So let's start by why do we use Python? I mean, when we needed to choose a programming language that will keep us as productive as possible, so definitely Python is the language that comes to our mind, and there are probably all the reasons most of you guys know that batteries included. Okay, so the variety of libraries is definitely a big factor for using Python, where we can focus more on solving problems and writing even less code, but structured, well structured, with an easy syntax and pretty much readable code. The learning curve, so probably anyone coming from any other language or even learning the first programming language. So Python is a very welcoming programming language, definitely. The portability is definitely a very important factor here, where you can run the code moving from your laptop to containers, to VMs, to the cloud is super easy. And the community, definitely the community is one of biggest advantages here for Python, because when you have problems and you have questions, you need answers as fast as possible, and with the Python community you have it. Okay, so I want to give you guys a few examples in JFrog where we do use Python uh, in our software development lifecycle. Okay, so let's start by when we need to provision and configure machines. Okay, so we use Fabric. Fabric is a library that actually allows us to run shell commands. Okay, everything using the SSH protocol, and but everything that you get back from every command that we run is a Python object, so it's very easy to manipulate any response and do wherever you want with all the objects that you get back. Okay, you don't need to install any agent in order to use this library. You just need SSH access to the machine, and everything happens. And this pure Python, so probably you guys you are aware of many different tools that can do the same thing, but I think that when you need something less opinionated and go to for pure Python, I feel that Fabric could be a good choice. Okay, so we use it mainly for creating in big setups. It can be normal setups or even high availability setups with very big topology. So it handles it very well, I could say. Um, Another example where we use Python is for in our pipelines. Okay, so Python libraries, they are very helpful, and they are very helpful while we are building our software and also deploying the software. Okay, so all over the pipeline, we can use Python, of course. For example, using a CLI-like tool like ArcParse is the simplest one, I would say, maybe because it's already built in, but um, creating just a CLI tool like you see down here that you can get parameters in the CLI and handle any logic from there. It's super easy. It makes also very easy to move from one pipeline and from one CI CD server to another. So you keep all your logic inside of Python of the code, and then moving from one CI/CD to another it should be very easy because all the logic is already handled there. Think about it. You need to handle many different REST API calls inside of your pipelines, talking to different services, getting different statuses. So, yep, nothing better than I think nothing better than Python to do it. Okay, using, for example, requests, or you just URL lib. So we can handle this very easily there. If you still need to use shell commands, you can go always to system or subprocess popen. I personally like more the subprocess popen approach, where you have more, I would say, granularity on what you send and what you get back. Okay, to handle everything, it's, for me at least, it's easier with the popen approach. Okay, and think about it also. You want, inside of your pipelines, you executed a lot of different tasks. At the end, you want to just get a report or different reports for each stage. So Python is there also, is already there. So it's super easy. You're using, for example, Jinja 2 template engine. You can create reports, very rich reports, dynamic reports for everything that is happening inside of the pipeline. Okay. Another example I want to go through is for end-to-end tests and benchmarking. The most common one, PyTest for functional and API testing. So it's being using all over the place. We have been using also for the last couple of years. We have been using Locust, okay, where we can. It's a framework, load test framework, where we can simulate different users going through the endpoints that you define the endpoints. Users go there. They go through all the endpoints. We have all the information about the response time and response codes, failures. We have all these statistics already built inside of the framework. So it's a good way also to understand how the application behaves with many users. Okay, we create our own Python client as modules. Okay, mainly API wrappers where we can share between different teams. Abstractions, where it should be easier to just go there and use any part of the public or internal REST API for any part of the platform. Context managers is a goodie for Python, and it's an elegant way to just create objects and use them, and even handle all the object creation and tear down of the same objects. You can see down here, I added an example where, for example, we create a client, okay, and you just create it once as an object, small object, and then you go there inside, you give all the logic that you need. Again, as modules that can be shared between the whole company, people from different teams sharing different clients. Satellite services, that's how I call it. So satellite services, it's you just in a few minutes you want to bring up a new service, okay, and you want to have a few endpoints where you can populate data and get data back from these satellite services. And with the Flask, for example, is a super easy way. We use it a lot. Okay. One more example is for machine learning and data filtering in jFrog. We deal with a lot of data, okay, especially data related to components, packages, open source packages, and security vulnerabilities. Okay, so dealing with all this data, when we deal with it, so it's very important to to have the right way to deal with it. And here we use actually scikit-learn, the machine learning approach, also modeling with the Spacey, okay, where we can classify candidates for components and finding the right security vulnerabilities related to the same components, and bringing more insights about CVEs and descriptions of the same CVEs, and bringing a lot of information that is related to security and licenses for the components. Okay. Yeah, where do we store our Python modules? So this is an important part of the process because, as I said, we share between different teams these modules. Some of them come from outside. Some of them, they are created in-house and just shared between the different teams in the company. So for external modules, for example, we cache them in Artifactory. So it's easy and we have easy and fast access, meaning that even if PyPy or Python hosted, they are down, you still have access to these modules. They are cached in-house, okay? And then we have also the internal modules that we create, and we don't need to put them out. We just keep them inside of the organization. It's very easy to share between each other. Totally integrated with the CI/CD pipelines, of course. Okay. And one important aspect of dealing with these modules, external and internal modules, is to scan for security vulnerabilities if they have some, and what is the level of the vulnerability, the severity of the vulnerability, and also for compliance. So licenses, which licenses are actually part of the same packages. This way, we according to legal aspects, we can understand if we can use or not the same modules. So this part is very important aspect of the life cycle, okay, the development life cycle. And yes, I think I would like to maybe get some questions from you guys. I'm open for questions.
Yeah, I have one for you, Daniel. You seem to use Python pretty much end to end in a lot of your DevOps processes and for spinning up API services. Has there been any cases within jFrog where you've found it to be maybe not a good fit, where you migrated to another language for specific use cases, or you use Python pretty heavily?
So in jFrog, actually, we use different also different programming languages. We use Java very heavily. We use Golang also very heavily. But Python, as you see, fits for many use cases. We have also new services being added to our platform today that they are actually written in Python. But we have different, actually today we have different technologies and programming languages for different services running under the same umbrella. I mean, the same platform. Okay. So yeah, Python. It's in Python. With Python, we want to make sure that the at least in my team, we want to make sure that the R&D teams, they are productive. I mean, just solve problems, you know, but we also use it as part of our services inside of the platform.
Okay. Thank you. It sounds really like just from end to end is so nice to see that the language is being used so heavily. I'm sure our community really appreciates that those opportunities exist, from starting from Fabric and using the pipelines, command line tools, rich REST APIs, System OS that you mentioned, Jinja for templating for reports, and Locust for load testing, which is a new one for me. But a lot of a lot of stuff going on there. Do you have a favorite Python package that you just really like, be it built-in or third-party, that stands out to you? And either it's like execution or how it abstracts away work for you.
I think Fabric, the first example that I gave, Fabric is we are using it heavily in our day by day, especially for provisioning and configuring machines. Yeah, this as a third party module, I would say Fabric, but yeah, we have also our clients that we develop in house, and they are very useful actually.
That's great. Yeah, I got introduced to Fabric several years ago by a mentor when I was going through the ChiPy mentorship project, and yeah, it's a great little package for controlling even one or several server instances that are remote. Really kind of helped me clean up my deploy process when I was a newbie, and just making things kind of repeatable from my laptop to an AWS instance. We do have a couple comments here. We have Sparksy saying it's really neat to see how Python's being used with so many processes in different ways throughout the process. We didn't get too many questions, but it's nice to see that comment from the community. So, given that we don't have any other questions, I think we'll call it on this talk. And I'd like to thank you again, Daniel, for your time tonight, for excellent presentation and showing really how Python is used in your business, really from end to end through DevOps and services and everything. It was a great talk. Thank you very much.
Thank you very much, Aaron. Thank you very much, guys.
Have a good evening. Hope to see you at the live stream, but at the after party. But I know you're on quite a different time zone and probably looking to get some sleep.
Yeah, I'm in Israel. In here, I am in on 2 a.m.
Well, thank you again so much for staying up and staying here and giving that talk. We've got a lot of things coming in on the feed as well.
That's great, Aaron. Thank you, guys.
Thanks. And then at this point in time, I would like to introduce Joe from Zoro. And hi, Joe. How's it going? I'd like to give a little. Great. I will let you handle your introduction and go into the talk. Thank you very much.
Great. Thanks, Aaron. Yeah, thanks ChiPy for having me. I'm really excited. I used to go to ChiPy years ago all the time, and I never presented, so it's a great opportunity for me. So I'm Joe Nealon. I'm a senior developer at Zoro, focusing on Python. I've been doing Python myself personally about 8 years, and then total development about 14 or so years. Daniel, that was a great presentation. I got to say, there was a couple of things that you guys used that I forgot to add to my presentation, so I might try to shoehorn them in. So let me just get started. So who is Zoro? Zoro is an online distributor of products for mostly business-to-business customers, but we do also sell to individuals. We focus on small businesses to find what they need and grow to maintain their businesses. Today we got over 8 million products available. I'll say personally, when I started Zoro 3 years ago, we had about less than 3 million products. So we've seen some outstanding growth there. And we work with third-party suppliers to provide products to fulfill orders for our customers. So because we're growing so quickly, we need a technology stack that scales at an equal pace. So why Python? So Zoro's been using Python longer than I've been there, since its inception about 10 years ago. But Python for us, it really allows our developers to create new features quickly and efficiently. And I think that's Python's greatest strength, is that it's easy to read, it's easy to write. So that gives us a competitive edge over other e-commerce platforms. we have seen some great growth in our products, but also in our development team. So now coordinating 50 developers in a single organization, it requires a language that's easy to communicate in. And so Python is, even if you don't know Python, you can pretty much read Python. So it's easy to communicate among developers as well. So our front end people can review Python code. So, and most importantly, last and most important is that the Python community is robust and thriving. And so that has been helping our technology group grow because, there's no shortage of great, just excellent Python devs in the Chicagoland area. Zoro itself is full remote at this time. I mean, but we do have offices in Chicago and Buffalo Grove. And so sometimes we go in there if you're in the area, but we're hiring for remote positions anywhere. Now I'd like to talk about where Zoro was and where we're moving to. So this is what we call the monolith, and this is a situation that a lot of companies that are seeing growth get into, and it's common because you usually want to start with a monolith when you're small, and then you grow into a more distributed system. So we have, and this is my presentation is going to be mostly web focused, but we do use Python for our ETL systems as well. So our main monolith is Django. Django does all of the routing and it does all the processing, and then it hands over context data to our Vue.js SSR, and then Django sends it back to the customers. So on that server, we also have our CMS, and then on separate servers, we have, product and category data. And then we have third-party providers for things like search, recommendations, text, shipping, and many, many others. We also have the ERP, which is separate. So Django is kind of like packing this all in there. Because it was a monolith, we could only deploy so often, and we were deploying once per sprint. So every 2 weeks, we would deploy, and it would just be like this massive, amount of code, and that can be difficult to steer. If there was an issue with a single feature, it could hold up the deployment for unrelated features. So Django itself was doing a lot of the heavy lifting, and most of our business processing was like actually synchronous as part of the customer request. So what did we do? We moved to microservices, right? Everybody's doing that. So over the last 2 years, we're trying to split up the monolith, and all of our devs, most of our backend devs are Python focused. So we wanted to stay with Python, but move it into microservices. So we chose Flask as our main microservice framework. So microservices, they either communicate through like REST HTTPS calls or message queuing systems. So there's some asynchronous communication, some synchronous communication. We don't use the Django REST framework, but we do what we use is something called Connexion, which takes a Swagger YAML, like an Open API contract YAML, and converts that into the routes. And so that lets us write the actual microservice code, business logic code in pure Python. And then we also have the freedom to move to a different framework if we need in the future, which also adds some agility. We've got like a kind of a Flask wrapper around pure Python business code. So this is just kind of a expanded diagram. This is extremely simplified, obviously for this, but I just want to go over some of the things that have changed, and this is some of the things that we have already. So we still have Django, we still have Vue, but it's just doing a lot less of the load. Django connects to our CMS, which is now separate. We're not using CMSDB right there on the same server, so we have a little abstraction there. And then we actually have our Vue SSR that is doing all of the connection to our Flask microservices. So now we've got a catalog service for products and categories. We've got a search service for our search provider. We've got a recommendation service for that. We've got a cart service, which then connects to our ERP, as well as tax and shipping provider, which are also behind microservices. So you can see that this has just been become a much more distributed system, and it makes our all of our lives a lot easier. So we build all those microservices on Docker containers. We deploy through Jenkins, and we use Kubernetes in the cloud. So all of the scaling then is handled through Kubernetes, and we can focus more on the actual business code rather than having to deal with performance on our servers. So the main benefit that we get out of this is that we can deploy those microservices ad hoc. So as the feature is developed, it can go right to production. The monolith still exists, but it's significantly reduced, and we can deploy that now once a day. So going down from a deployment to every 2 weeks to once a day, and including being able to do more focused deployments 2-3 times a day per service has definitely helped us there. So I just want to show you a little bit of our code. This is an example on the right here of what the Open API or Swagger YAML looks like. See, we have our paths. I wish I could show you more of this, but we have our paths defined there, and whether it's post or get, and then the actual link to the Python function that runs when you make that call. And then we can also define our request and response bodies so that we don't have to actually write any code to validate requests and responses. It's just they're just all right here in the YAML. This is basically. Oh, I clicked. This is on the left here is basically the extent of how we use Flask. We just build an app and we import the YAML, and that does all of the routing for us. We also have Flask handlers, which I don't have included here, but that's things like 500 error handlers before request handlers, after request handlers. So what are some of the obstacles that we ran into when we moved to this system? So growing at the rate that we're growing, both in like amount of data and amount of developers, we need to learn to be flexible quickly. So most of the teams are already agile, but some of them were working on like waterfall pattern projects. Now all of our teams are on either agile or Scrum or Kanban. We also moved from like a dozen repos to hundreds of repos, which requires a lot of coordination. We adopted the Git flow pattern across all repos because, I mean, whether you think good Git flow itself is good or bad, at least it's something that is defined and that we can, like, everyone can agree on. Also, versioning is essential. With these microservices, we keep track of, we version them all before they're deployed, and then so rollbacks, we can easily roll back to previous versions. We can also deploy a single microservice on multiple versions for things like A/B testing and experiments that we have. So what are we doing in the future? We plan to eliminate Django from the main web server. I love Django. We all love Django. Then there's nothing wrong with it, but the web server itself contains a lot of legacy code that needs to be disposed of. So we'll still keep Django on the back burner for specific microservices that Django would be good for. But ideally, the entire front end is going to be JavaScript driven, and then the back end is going to be mostly Python microservices. And so one thing I didn't include here too that I wanted to talk about was that for testing, we do, as Daniel mentioned, we do use PyTest. We moved from the Django test to PyTest about 2 years ago, and that has definitely improved both the writing of tests and the reading of tests. And then we also use Locust.io. Locust, even our front-end team uses Locust for their load testing and performance testing, just because it's so easy to write user behavior, and so we've had some success there. So that's all I have here. Thanks, thanks everyone for having me. I have some light Python documentation for the packages that I mentioned, although those I'm sure you can find. And I've also included a link down here to our career section. We have we have a lot of positions open at Zoro, and we're constantly recruiting. We want to be Chicago focused, but if you are remote, we can do that. And you know, reach out to me, and I can connect you to who you need to talk to. So if there are any questions, I can take them now.
Hey Joe, that was a great presentation again. Thank you very much. We do have a question coming in on the stream. How do you perform your integration testing, A-staging, environment, and feature flags?
Okay, so we'll start with integration testing. We have a variety of ways that we do integration testing. Most of them are using Postman. So we actually, we have Postman allows you to export to JSON, so we have those committed to our repos, and then you basically import those in your Postman to run tests. We also have some of our services are using packed flow, but that is not fully implemented across all of them. Packed flow allows you to do contract testing rather than integration testing, so that you actually just a microservice that talks to another, or the front end that talks to a microservice. You define the contract between them, and then you can test without that microservice actually being running. And then that also gives you a nice diagram. I could do a whole presentation on that, but it gives you a nice diagram of different microservices that and how they talk to each other.
So obviously you've gone through, talked in your presentation about going from the monolith to more microservice type oriented architecture. Did you have any pain points with that, or did it go smoothly? What did you learn through that process, and maybe what were you done better, or what went well?
So there were a lot of pain points. I mean, this is quick growth, right? So you're going to run into a lot of things. We were developing our tools are sort of like the glue packages that we wrote to keep them together as we were releasing production microservices. So those needed updates, and then that means that you had to do updates in every microservice. We tried to limit as much duplicated code as we can using something. We use Cookie Cutter.
Okay.
So Cookie Cutter we have like a base microservice that you could do. You run Cookie Cutter, it just gives you all the guts, and then you can write your Python code in there. I would say opening like 10 PRs at once that all have the same code. That's definitely a pain. But we've gotten to the point where we've removed a lot of the necessity to do that.
Cool, that's great. And we do have a comment the same as. We do have another question. How do teams coordinate changing contracts between services?
So we have we have our Scrum teams, and microservices are based on a domain. So your Scrum team, you have ownership of the front end code that's in that domain, and as well as your microservices. So coordination should be within that team. For coordination outside of that team, we do have like a Scrum of Scrums that's usually run by senior and staff level engineers, and those are usually just like higher level things.
And then I think Daniel wants to come in and ask a question about your presentation as well. I'm going to add him to the stream here if I can still find him. Jordan. There we go. Daniel. Hey, Daniel.
Hey Joey, hey Joey, thank you for sharing all this stuff. Just a quick one. The declarative approach for the endpoints. It's a very nice one. I just would to understand in terms of maintenance. Okay, when you have different microservices, right, and then they probably have different endpoints, each one of them. So how do you maintain it, this?
So how do we maintain the contract YAML? So we often, so the good part about having these contract YAMLs in the declarative way is that the front end people that are writing the code that consumes them, they can actually, well, they can read it better, and they can actually edit those themselves. So sometimes we'll have a ticket that update like the logic as well as update the contract. But then we have to make sure that we coordinate the deployment with the front end that consumes the contract. Since we can deploy microservice ad hoc, that seems to be pretty quick and easy.
And then we got time for one last question, I think. We have Joe Janisic asking, do you have any general advice for splitting out into microservices, database migration and state, managing shared code, etc.?
So first of all of our microservices are stateless, and so that was an architecture goal from the beginning with. Any state should be managed in database, and so that's definitely been helpful for what we've done. We're also following domain-driven design. So our architecture team, they got together with various business people, and they defined what are the business domains at Zoro, and then we decided which microservices go into those domains. And so by having that sort of like split between the domains, that's helped figure out what exactly needs to be pulled onto the monolith.
Sponsor of ChiPy, same to Daniel and Zoro, Daniel and jFrog for supporting ChiPy as well. I think we're at a point here. We'll take a quick break, and I'll post the slide again for the raffle, and then maybe in about 2-3 minutes we'll come back to Patrick Fuller and his presentation about how Python is being used at NuMat for clean air technologies. So thank you very much. I'm going to take a break, and we'll be right back. Hi, everybody. Welcome back. We'll be continuing the presentation here shortly. Just want to remind everybody again about that raffle from jFrog for the Adafruit Clue. Please click and enter. They've got 3 of them to give away, and they look really neat. Our next speaker will be Patrick Fuller. Hi, Pat. How's it going?
Hi, Aaron. Doing well. How are you doing?
Good, thank you. Thanks for coming out tonight. I know you got probably some really interesting stuff to share here with everyone, kind of a unique business and unique use of Python. So please take it away.
All right, thank you. Yeah, to start, I was just going to introduce myself really quickly. Very similar to Joe and Daniel, I'm going to probably piggyback a lot of their background and what they presented. I was a chemical engineer by training, but I really got my start in the Python community with ChiPy circa 2010, sort of 2010 to 2013, ChiPy, PyCon, that sort of thing. I absolutely fell in love with the community. I was a permanent lurker, never gave a talk. So I'm actually really excited to be here giving a talk on a topic. This feels like a full circle event for me. So really appreciate the opportunity to do this. One sec. There we go. Okay, so I want to give a brief background on what we do. So as Aaron was saying, NuMat's sort of a unique company in this space. So our product is not software. We're not externally exposing an API or selling software. Our product is actually a physical technology. So the really quick, enough for us to move forward explanation is we make the stuff that you might find in your face mask or in a Brita water filter. These are materials that block biological agents, chemical agents. You've gotten very familiar with them, unfortunately, over COVID. But we make fancy versions. So the things that we make are, we like to say 100 times as good, but 1,000 times as expensive. And what we do as a company is we find really interesting niches where people really, really care about performance. As you can imagine, some types of first responders want something that's much, much better than may be available to all of us. Also industrial systems, there's hundreds of applications when you really start digging into it. So that's what we do at a high level. I'll do a quick plug. There's lots of really nerdy science papers out there on the topic, but if you're interested in the technology and just want to learn, me and a couple of others made a video about 10 years ago now on the right here that gives you a high-level overview. It was also talking about Python. We did this video completely in Python and Blender. So it was a really good learning experience at the time, and we went around and taught others how to do that. If you haven't played with it, it's really enjoyable, and I'd recommend it as a way to get better at Python. All right, so the question of why Python? There's quite a few reasons for this. If you look at our company, imagine a company that's making a lot of physical products. We're a lot of chemists, chemical engineers. There's a lot of people with PhDs at our company. They're all very smart, but there's not many programmers in comparison. So you have smart people who don't necessarily know how to code. Our mission as the data engineering team at the company is to use modern software and data practices to accelerate innovation. What I found and what's really been addictive about Python to me and others is not necessarily the advanced Python you can do. I think that's really interesting, but instead taking someone who is smart and teaching them just enough code to solve a problem that they have. So something that we can do at NuMat, which is great, is you basically give someone a copy of Automate the Boring Stuff. They get it in their head. They start to recognize the workflows that they can get rid of and automate. And then they can do that themselves. And what at least I found is it's amazing the inefficiency of workflows people are willing to go through just so they don't bother you with a question. So even though you might be an experienced developer who can help them, giving them the tools to solve their problems is really going to enable them. They're going to come to you with questions about what to do next, as opposed to having that barrier and continuing the inefficient workflows. So that's really why Python at a high level. It's just that ease of adoption and that time to get that sort of addictive feedback loop that really good programming offers. The other thing I'd say is as you work with people to automate the rote side of your job, of their job, what you see is they kind of get pulled out of the weeds and have more time to think strategically. So you have a chemist who's now, not worried about what temperature is the reaction working on. They can go leave that and start thinking about, is that the right reaction? Am I on the right path? So the more you can automate and get people's brains out of the rote day-to-day tasks, the faster you really do see innovation going. So that is why Python. In terms of what our day-to-day is for people who are full-time programmers at NuMat, I break it up roughly into 3 sections. The one we got our start on was computational modeling. So I'll show some screenshots of that. That's pretty interesting. We expanded there to equipment automation and business intelligence. And then there's some sort of rote IT stuff that we're able to do pretty well as well that we won't really dig into. So when we started NuMat, we were actually a material design consultant shop. Our pitch was that we would use software to accelerate material discovery. While we found that no one really cared about paying for material recommendations, they just wanted to buy materials that already existed, we saw a ton of the value in the approach. And so even today, we keep these services running for internal use. What you see on the left is a Similarity search tool we have. So this is a Django app. We use data tables on the front end, Postgres back end, and we're able to rapidly query it. So this is Django REST framework. We're able to basically get that integration going so you can query fairly large databases relatively quickly. This has been a really sort of fun and interesting tool. There's a million ways to expand it. This is one of those internal tools that if anyone gives it a day or two, they'll end up making some interesting new feature and rolling it out pretty quickly. The other thing we do, and answering the question of what's my most interesting library the last year, I'd have to say Dasc. So Dasc is a HPC platform that works amazingly well. We've been able to use that for a lot of our computationally heavy loads. So we can do things like spin up 50, 100, 200 Amazon cores and get those just chugging on some pretty complicated math and have that come back in while monitoring it the whole way. That really did automate a lot of custom scripts that we had before using libraries like Boko. So it was really good to get that change going. The other thing we do on the right here is we're always testing the waters with new internal apps, trying to see ways to help people out that we might not have today. So we'll start with a Jupyter notebook, which is very straightforward data science tool. See if that software is helping. If it's helping, people are willing to go through the learning curve of the notebook to run it themselves. Once we get some traction there, we'll take that notebook, convert it to a Streamlit app. So Streamlit's a really nice, pretty straightforward app architecture to convert a notebook into an interactive user interface. And you can do quite a bit of that. Once we get a few iterations on that Streamlit app, we then move it into our big Django monolith because we have a Django monolith. And really, that's where it starts to become more of a maintained piece of software. So while material discovery is cool and it's what we started with at the company, it is sporadic. You can discover a new material in a couple of days of work, but you need months of research time, years of engineering time to get the material right. So this led us to looking at how can we use Python to help the company elsewhere. We pretty quickly recognized, partially because it was really fun, but also partially because it was helpful, we could automate many of the actual physical processes done in both the lab and plant. So, it's really cool. It's really rewarding to write a script where you can toggle things in the real world. You can flip a valve, turn on a heater, move an arm. There's a very powerful feedback loop when you do that well. So it's genuinely addictive, but also helpful to the company. So what we did here was we started with Tornado at the time, but we moved to async IO as that started to stabilize. So Python async IO, AIO HTTP, and we make an asynchronous server that can read a whole bunch of devices, different communication protocols, what have you. They can read dozens of devices. They aggregate that all into a single data structure, throw that into Postgres or Mongo, and then basically expose a WebSocket endpoint that we can then write a pretty thin HTML JavaScript layer to read and render. So what you're seeing here is the HTML or SVG in JavaScript on the top right, which is a pretty small fraction of the overall code, but what the end user actually sees. We've done quite a bit over the last few years to get this workflow really automated. So when we started, everything was its own independent app. We had a lot of duplicated code, services that could be shared. And what we've done over many iterations as we've built over 100 of these systems now is narrow it down. We're at a point today where we have a YAML file with a custom parser, and essentially someone who doesn't know too much code can go into that YAML file and change how the code works. So the code that'll include sets of instructions, things like that. There's even some special keywords that we've added on top of it that allow us to say loop things or do things in different ways that are more pertinent to control systems. So we've put a lot of time and effort into this. We're looking to move forward on this to continue this idea of automating. One thing that we've expanded the company is for safety reasons and making sure people have thought through things. Any engineer or chemist who builds something has to fill out what are they building, what does the process look like, what are the sensors. So our goal, and I think we can get there, is can we take the documents they're filling out and then ingest that into something that immediately pops out the control system based on the quality of those documents. So we think that could be really interesting. That's something that doesn't happen in the field today. And the mismatch, not having one source of truth between the documents and the code is something that has led to issues in plenty of companies in our space. So really interesting area. Once again, the addictiveness of being able to flip a valve with Python is just amazing, and something, if you haven't done it, I recommend doing it. Even just getting a light bulb in an Arduino. Oh, and one shameless plug here. So if you're interested in how software talks to equipment, I wrote a blog post about surviving a zombie apocalypse with control communication. We have more thorough internal documents on how all this works, but for external, I thought the blog post would just be a really fun way to get someone started in the field and understand, what is it you have to do to automate real large pieces of equipment. It's pretty interesting. And then finally, as the company started expanding, so we got to our first manufactured product, other products were coming down the pipeline. We recognized the need for an ERP system. We ended up building this all in Django as well. So we went to ERP vendors and their prices were scary high. And that really led us to doing this. And there was a lot of benefits. So going back actually a few slides real quick to what's called the ERP pyramid. This pyramid here on the left. If you do it right, your ERP system should link to your manufacturing systems, which should link to actually the equipment you're building. The PLC and SCADA. So SCADA is Supervisory Control and Data Acquisition, just an acronym for Equipment Automation and Robotics. So what we've been able to do, going back to our business intelligence side, is we can link particular sensors, temperatures and reactors, and aggregate that all the way up to a CEO level view of the company. So at that top level, you can see your sort of money in, money out, the things a CEO might care about. And then you can drill down to, things a department director might care about, such as number of samples going through the pipeline, things like that. And you can drill down to how long are you reacting each of those samples. So you can get down from the sensors all the way back up to a financial view. This has been really wonderful for our manufacturing systems and is a really unique capability. I'm glad that we were too poor to afford an ERP, because it's really enabled a lot of cool stuff. And that's all I have. We are hiring. We're looking for software developers, but also we have friends who are chemists, chemical engineers. We have jobs across the board. Feel free to reach out to me. I'll try and join the ChiPy town hall after.
Great. Thank you very much for that talk, Patrick. A lot of interesting things going on there. Yeah, the physical compute thing seems really interesting and challenging. Interested in kind of how you are moving, Python out from just software developers to engineers and other users, and basically like your YAML file, and moving to like one single source of truth with basically the requirements, right, being the code at some point in the code generation. How has that been, and has it been a challenge to get to that point? Have users been receptive to that type of implementation?
Yeah, you always get a mix of responses. So what we've done at the company, and I think what anyone has to do at any company if they're being honest, is find their champions and identify their laggards. So find people who are willing to fight through, basically be beta testers, fight through the early bugginess, they see the vision of it, and get them bought into a new idea or concept. Get a couple iterations with them, and then roll it out to the broader team once it's debugged. Because every company will have people where if it breaks once on them, you're going to have a hard time getting them back. And every company also has people that will allow it to break on them every hour, and will just keep telling you because they see the big picture. So that's been how we've been doing it. The challenge always with documents is any free form field. People are never as accurate as coders when it comes to filling out, say, an Excel sheet or a Word doc, right? So if you're trying to parse something that's truly free form, you're going to have a hard time. We can make forms for part of it, and we're working to figure out how do you do forms for more abstract parts of it, like when you draw a process flow diagram. That's a drawn diagram. So how do you convert that into something that can be really consistent every time?
Okay. We also have one question here. How do you automate your deployments, or do you even do automated deployments? I know you're kind of a smaller shop, and in that
we are a smaller shop. We do have post-commit hooks on Git. Our deployment is Docker Swarm, so we actually have a couple of servers, and you can take one down and the others stay up. We're pretty concerned about redundancy on our internal systems. For some security reasons, a lot of our systems actually have to be internal and not on the cloud. So our industry kind of has some weird requirements there. But yeah, Docker Swarm. Sometimes we've done the sort of the deploy hooks. Other times we don't do that because it's easy enough to just SSH in and pull it.
Okay. Cool. Thank you very much. Appreciate the talk. We look forward to seeing you at the after party.
Thank you.
Thanks. And with that, we have two more speakers. Next individual we have is Santiago.
Hey, how's it going?
Good. Welcome.
All righty. Yeah, I can get going.
Drop off.
Yeah. So yeah, hello everyone. My name is Santiago Santana. I'm a principal engineer at Narrative Science. Today I'm going to talk about what Narrative Science does as a company, our main product Lexio, and similar to Joe, our journey from what we call our pseudo monolith to microservices, and how we're utilizing Python's ecosystem to make it easy for developers to work in a microservice architecture. So we'll start with Narrative Science, what it is as a company. So Narrative Science is a data storytelling company. But what does this mean? It means we connect to a customer's data warehouse or SaaS products such as Salesforce in order to analyze their data and generate insights as written reports. To the right is a video of these stories that I just mentioned being written in our main product, Lexio. As you can see, Lexio presents users with insightful stories that are written in real time. And I'll play it again just so you can take a look at it. But one of the interesting tidbit about Lexio is we process 18 plus terabytes of data and deliver 165,000 stories daily. And it's all done in Python. Why Python? Well, the biggest reason is well known. A lot of engineers have heard or have used Python. There's a lot of information on how to do things in Python on the internet. On Stack Overflow, there's tutorials. The PyDocs are actually pretty well vetted and fleshed out. It makes it really easy for engineers to get up and running, especially if they've never worked in Python before. And that's really important for us because Lexio is a very novel product. There's not a lot of things. It's not a lot of big market for data storytelling, and there's a lot of intricacies that go into it, such as natural language generation, artificial intelligence, things like that. So using a language that has a quick startup and a wealth of resources is actually really valuable for us. So the second point, which is kind of maybe the main point of this talk, is that Python has a really rich ecosystem. has been mentioned by all the talks before. There's a lot of libraries for like type validation, database query management, web frameworks. So that means we can really focus on business context instead of kind of reinventing that wheel. You know, you hear a lot about Python, you know, have a reputation for being slow. And while it's not the most performant language out there, the speed of libraries like Pandas and NumPy make it one of the most popular choices for data scientists. And we leverage that with our data analysis. So all of our data analysis is actually done via Pandas right now. And then I'll kind of go into this architecture so you can kind of see how we use that. So we're gonna change gears and talk over more about Lexio's architecture. So I mentioned Lexio is a pseudo monolith. It's a monolith in the sense that it is a monorepo and it's deployed all as one through one pipeline. However, we do have several services. The main ones I'll call out are data ingestion, data operations, and runtime for this architecture. So this is kind of a high-level architecture showing the flow for how we write stories. So when a story is written, it gets a call into the runtime service. And the first step in writing a story is to figure out really what to write. So the main job of the component Lace, which is the Lexio authoring and content engine, is to figure that out. Lace uses the ontology to understand how fields in the user's data relate to each other and what content is actually worth talking about. Once Lace has figured out what content's worth talking about, it actually needs to query the data to get those insights and those values so that it can present that in the story. One story write can result in over 100 queries to our data operations service. And the data operations service will actually do that in a matter of seconds. A query can actually encompass anywhere from 10 to 20 analytics. So you scale that out, and that's quite a bit of analytics in a short amount of time. Once Lace has the full grasp of information for the story it should present, it'll hand all that off as a giant graph to NLG, where that process will turn it into actually written language, and that's what's presented to the end user. So you may be wondering, you know, like why, if it's working for us right now, why we even, you know, want to switch to microservices? And it really has to do with that monorepo, amongst other things, but the monorepo has really been the biggest reason for why now. And the first thing that we noticed, similar to kind of what Joe mentioned, slow deploys. As we're building this product up and adding more and more features and functionality to it, the tests just get longer and longer. The deploys have to deploy more. Everything kind of just gets backed up, and it takes a really long time to get something out. Even though we've been doing CI/CD and we do several releases throughout the day on a good day, it's still getting slower and slower, and we want to kind of speed that back up. The other issue we run into a lot is CI/CD issues, such as you have a bunch of engineers who merged code, and one of them merged something that broke the pipeline, and now it's blocked for everybody who merged that code, even if, you know, a couple of the things that were merged were for services that should have been unaffected by the broken merge. So this is not a great issue to have, and we've lost days to these kind of problems. One of the things, to go into more detail on that, is, you know, we call it the bystander effect. So for those of you who are unfamiliar with that, it's the effect of, you know, if there's somebody who witnesses an issue, they're more likely than not going to address that issue. But if there's 10 people who witness the issue, each person is kind of going to assume the other 9 are going to kind of address it, so they don't address it, which means they end up nobody addressing it. And we see this a lot in those merge issues that I mentioned just a minute ago. We have 10 engineers who merge something, the pipeline's broken, everyone kind of just assumes someone else is going to look at it, and then we lose a lot of time. And we're really trying to move rapidly here. So microservices and breaking those up into their own actual deploys with their own stacks and everything makes the most sense. So that's the why. Let's talk about how. And a lot of it has to do with leveraging Python's ecosystem to really have the engineers focus on the service they need to build and not all of the extra stuff. So to make our product as robust as possible, we do utilize a lot of third-party products and services. We use New Relic, we use AWS, we use Sentry, we use Dapper. All of these services and products have Python libraries that we can use to interact with them. So we can start to, utilize those libraries, integrate them in our code. And then secondly, we can actually start to write, libraries, utility libraries around these products for our use case. And that way engineers who are working on their microservice can actually just worry about, oh, I'm interacting with this library, this is great. I'm just like, I'm doing logger.info, but it's really going to 5 different places because we've built out these really rich these really rich utility libraries that we publish to our private PyPy repo. Now, we also do publish out open source things. So we leverage both the public and our own private repo, which has really helped us with speed on development. The last point is really that we are leaning a lot on Python's async framework, async.io, which was also mentioned previously, to maximize asynchronous calls between services and databases. This, it makes code a little bit more complicated dealing with the event loop, but it actually, helps us leverage a lot of wasted time that would be there if we were using non-async, where we're waiting for these calls to come back. So we can gather a lot of calls that we need to. We can hit the database and an API at the same time, and when they both get back, whenever they both get back, we can continue on our work. So that's kind of the how, and I want to show a little bit of examples of how we're really leaning in on this stuff to show, like, if you were an engineer on a microservice, how everything's kind of abstracted for you, and you just have to worry about the core domain and goal of your microservice and building towards that. So the first example here is an example of how we subscribe to Dapper topics. And so Dapper is an event-based runtime that can be used for both inter-service calls as well as asynchronous event-based messaging. In our case, we wrote a shim for Dapper to use it with Kafka and Debezium so that we can do change data capture, and you treat that as another message that's coming into Fast API as like a service call. And so all we have to do to really subscribe that is this piece of code right here, where we have the topic subscription, we provide the topic, that is the Kafka topic, and then the route, and that's the route that is going to get, the API route that's going to get hit for that service. So when a message gets hit, when a message comes in, it will pass it to that route, and then we can treat it like any other web request, and we can do what we need to do to process it. This makes async message handling a lot easier, and it streamlines it so an engineer who's working on a microservices doesn't have to know, oh, was this async? Was this direct request? It's just worrying about requests coming in, handling them, and then sending requests out. Another example of using Python abstractions and really doubling down on object-oriented program design is this function call. This is a pretty standard function call for us that's inside of a service. And if you look at this, it looks like, okay, great, it's like basic object-oriented programming with a little bit of async here and there, but really under the hood, this is actually communicating with several services. It just doesn't look like it. So at the first example is that line modelfield.get. Well, what that's actually doing is it's using Pynocular, which is an open source project that we published, and it abstracts away database requests and treats them like they're objects. So that get is actually getting a database record from the database that is associated with this service, loading it, turning it into a Pydantic object, and then returning that as part of the get. So now this function is just really just dealing with Python objects, but really that was a database request. And then secondly, that get entities type on config client, that's actually an async API call to one of our services to get the entity types associated with that model field that was pulled from the database right above it. So then later on in this, we do our business logic of updating expressions and things like that on the associated entity types. And then we're appending this to a list of updates, and that second to last line of the gather is actually doing a series of async API calls to another service to actually do puts and update every single expression that's related to that model. So again, going back, it makes it very easy for someone who's familiar with Python to kind of just work in this framework. They just treat it as normal Python code, but under the hood, we're actually calling out to a bunch of services. We're modifying databases. We're going over the network, but at the end of the day, it's really just, a dozen or so lines of code. So really that's all I have. And it's a little short. But here's some of the resources that I want to lean on and just really call out, because we've really leveraged a lot of these to really make meaningful strides in how we build our microservices. So like I mentioned before, Pinocular database framework, an async database framework that we use, Dapper, portable serverless event-driven runtime. Boto 3, I'm sure most of you if anyone's dealt with AWS and Python, you've used Boto 3, an amazing library and super rich. You can pretty much interact with all Amazon resources through it. Pydantic and FastAPI are super cool libraries that work very well in tandem. FastAPI is a high-performance web framework similar to like other web frameworks like Flask, although it's async. So like AIO HTTP that was also referenced before. But the neat thing about FastAPI, if you're not familiar, is that the input and output of it are all defined by Pydantic models. So instead of doing this whole like request.json that you normally would have to do, you get this Pydantic object, which is just a Python object that has type validation and gives you all those niceties, and you can treat like that input that comes in from the request as a Python object. Lastly, Poetry, a really awesome dependency management tool. There's a lot of dependency management tools in Python. We've used quite a few in our time developing on Python throughout all of our products. We were using Pants before, and we kind of moved to Poetry now. It makes it really easy to isolate dependencies in different projects and really keep your dependencies locked and specific to your service. So with that, that's all I have. Any questions?
Hi, Santiago. Thank you. It's really good to talk about how all the different Python libraries and stuff you're using. Personally, I'm kind of interested in your use of Poetry, because it's been a pain point, right, for a lot of people in the Python communities over the years of like dependency management and keeping a virtual environment, some movement. How does that compare to say like something like PyPNB Poetry, or kind of mention some of the strengths of why you landed on it, but just maybe elaborate on it a little more.
Yeah, I think kind of the same theme of the talk is like that level of abstraction you get. Poetry kind of just handles that all for you, that isolation, that setting up the end for you. So it's a lot more user friendly and a lot less steps that you have to usually take in order to get that set up. As long as you have you can do, you have your environment, you have your directory, you have your Pi project toml, and then you can just kind of add your dependencies if you want. You can update, install, and it just kind of, you get that lock file, you get all the benefits of locking your dependencies, but then you can move around to different directories and everything. It isolates it better than any other dependency management tool I've used in the past, while also being extremely user friendly, which I think is just like a winning combination.
Cool. Yeah, I think you hit the nail on the head when you said abstraction tonight, right? Like that seems to be like a really key strength of all these businesses have identified in Python, is the level of abstraction that you can get with Python, and the ease of use, right? Just kind of like a blending in the background and letting the engineers and other users actually get their work done. So has that been kind of like your experience then too? It seems like it is.
Yeah, totally. It's been huge for us because especially in our case, we have a pretty small engineering organization, but we're trying to do a lot, which requires engineers to kind of jump from project to project. And so when they're doing that, having a good base that's like, hey, you jump in here, you run these few commands, and you're good to go. You just have to worry about the business, like goal. You have to worry about like what you're trying to accomplish, and not about how all the communication, all the infrastructure, all of that. It really ups your velocity.
It's great. I'm looking here just to see if we have any other questions coming in through the comments. I don't see anyone else there. I just want to thank you again for taking the time to come out tonight and present. Really great topic, very interesting, and I hope to see you at the after party.
Thank you.
Thank you. And then our next speaker will be Jordan Bettis from Nielsen. Hi, Jordan. Welcome. Looking forward to your talk. Jordan, we're having problems hearing you right now. Are you on mute?
Hello, can you hear me now?
Yes, I can hear you.
Okay, cool. Thank you. Yeah, so thanks again, Aaron. Sorry about that. So yeah, my name is Jordan Bettis. I work on the data science platform at Nielsen, and we'll get into exactly what that is a little bit later. But one thing I wanted to do actually, first of all, is maybe somewhat apologize. This is like my 5th talk, I think, at ChiPy that I've done. This is the first like Python Power Business Night talk I've given. I remember there used to be a rule that you got to have like code on your slides, but I thought, well, this is business related, so no code. So I don't know if you get upset with me for not having any code, it's because I didn't understand the format. So anyhow, so yeah, so at Nielsen, actually, let's go to the next slide and see what that is. Yeah, so basically at Nielsen, this is a company that's been around. Actually, I skipped a slide. There we go. This is a company that's been around for like, I think over a century at this point. And sort of fundamentally, we've always been, before like even people talked about data or talked about data science, we've been like a data company, a measurement company, a data science company. Back in the day, it was like statistics or whatever, right? But what we do specifically is we have basically 3 businesses that we're involved in, all related to the data, the audience data surrounding media consumption in the United States and in a bunch of other markets, right? So sort of like the main component of our business is audience measurement, right? And that's the largest part of our business. And what that is it's like really relatively straightforward. We're answering the question like who watched what piece of content when, and by who we mean like members of a demographic, what piece of content. There's like lots of types of content. For Nielsen specifically, it's audio or visual content. So, we're not necessarily who read a newspaper or whatever, although, that is in there a little bit. And then when is like fairly self-explanatory, I think. But that is actually something that, changes. Like historically, media consumption in the United States was pretty much, other than cinema, everything else was like broadcast at a particular time. We call that linear television. And that includes like over the air, cable, satellite, that kind of stuff, right? But of course now in the past like decade or so, we've like sort of seen a gigantic shift from linear TV to streaming on-demand television. Hulu, Netflix, YouTube, Twitch, that kind of stuff. And then Nielsen is also audiovisual. We're also in the audio game. So, radio and podcasts and, that kind of stuff, right? And so, one of the things that we do is we produce, you've probably heard of the product called Nielsen Ratings, or just like ratings. You probably on television, you hear people talk about like the ratings for this show, the ratings for that show. That's us. That's what we do, is we produce those ratings. Okay. And we call that internally, we call that audience measurement. The other thing we do is we take that audience measurement data and we produce value add products on top of that for manufacturers or advertisers or people who are deciding what show they should make next, for instance, right? And we split that into two different business units. One is outcomes, called outcomes. The other one is called planning. Outcomes is, I gave an example, like we have this product called mixed modeling, and asks the question, given a particular purchase of a product, what percentage of that purchase can be directly attributed to individual marketing campaigns? So like if you use like soda at a store, right? And a person purchases the soda at the store. Well, maybe they purchased the soda because it was there. We call it distribution, right? Or maybe they purchased it because they saw an ad for it. What they did, what ad, or maybe they saw multiple ads, right? And that attribution product is like, we can tease out, what were the ad exposures that led up to the purchase. And then planning is sort of the opposite, or the other side of that, which is like, if I were to run an advertising campaign, what would be the effect on my sales? And we call that sales lift, right? So you can imagine like outcomes and planning, that's just all data science, right? And actually audience measurement, which I'll get into a little bit later, it has enormous amount of data science. So we do data science basically all over our company. And accordingly, like our data science org is gigantic. It's actually split up into 3 different organizations: data science, and then like the outcomes and planning units. Overall, I think there's, 1,000-ish people overall who are in like the data science organizations, the various data science organizations at the company. And so what the data science organizations have historically done at Nielsen is they develop the methodology for these models. But when the model needs to be productionalized, which I'll get into later, typically they've handed it over to like data engineering, which traditionally has sat in technology. So there's a wall and you hand it over the wall, right? And then they productionalize it. The data scientists themselves historically have used like SAS and spreadsheets, just basically anything you can imagine. We used to have gigantic SAS clusters though, so that was one of the biggest things. I mean, there's more modern stuff like Databricks and that kind of stuff in there as well, but just like a huge kind of pretty much whatever, like whatever the team felt like using, which, to be fair, is like good for the team. And a lot of these products like are like, I think, like a smoother experience for data scientists in Python, but there are problems with productionalization, which I'll get into in a little bit, right? So I just want to kind of hammer home just like how this division between data science and tech has traditionally worked at this company. Data scientists, they develop a methodology, and then once they're happy with it, they pull in test data. They do model selection and feature selection potentially, or like fitting or, whatever, depending on what model they chose. They produce something that they think they like. They then have to set up a bunch of meetings with tech, explain how it all works in the technology that they use that can't be productionalized, like R or whatever. Or even like worse, like SPSS or something that just runs on a desktop, right? And then tech has to take over and learn how the model should work from DSI, and then re-implements it, in a language that they can maintain long-term, which is, is usually Java. And then they have to go back to data science and say, okay, did what we wrote, what we built, is it the same thing as what you built? From a statistical perspective, like, does it produce does it produce valid results, right? And then what happens is, like, if we want to change things, which we do relatively frequently, data science wants to develop a new methodology. We pull in a new data stream. We want to add it to it. Name your change. You have to do all this stuff all over again, right? So what we decided to do, and this is sort of where Python and also the platform that I work in comes in, is we decided as a company that data science should take ownership of productionalized model code. If data science owns the methodology, they own the code in production. And that means that they're going to take over roles that were sort of historically, what we would have called like a data engineering or an application development. at least with respect to that component of the pipeline that actually does the modeling. We still have all that, people in tech doing other stuff, but they're not working on the methodology specific. They're not working on modeling where DSci owns the methodology specifically. DSci itself owns that. The other big thing that we do, and I sit in tech, and my team does, is that we're responsible for building the platform that DSci uses to productionalize their code. So, like a lot of people, like in earlier talks, have talked about the problems with, SDLC, or the problems with productionalization, or like how do you get the code into production, or how do you make sure that the code is of a consistent quality, or how do you, validate that it's not going to choke on data it hasn't seen, right? That's sort of my team's responsibility, not to actually do that to models, but to make sure we have the tooling in place and sort of the guidance and guardrails in place so that DSci can actually own it themselves, without it burying them and, stuff that it's not really their concern. And so to drive this home, basically, like for our platform, we said, okay, like if you look at one of these like modeling pipelines that's been productionalized, you have the actual modeling itself. You have the data, which sits in the data lake, which is another platform team. And then you have, as I mentioned, you have the management of the code quality gates, the coding best practices, and also the release management. That makes it, how you release something into production. And then finally, you have like the infrastructure that takes to run it. And at Nielsen, our data lake we measure it in petabytes, right? Like we have individual queries that are terabytes, like the query result set, which comes back. So for us, like everything is big data, right? It's like, people use big data from their notebooks, right? So, so infrastructure is a huge component of any product that we build. So then, what we're doing with our platform is we're saying, well, data science owns this, right? And they're going to continue to own this even in production. And that's the big change from how this company used to work. We put all the data in the media data lake. And then the Intelligence Studio compute platform manages the infrastructure, and also that SDLC process. And I want to, sort of reiterate, like for us, the SDLC process is a component of the platform. It's not something that I'm physically doing. It's not something anybody on my team is physically doing. It's something that we're, like for instance, the platform enforces that you have to have code reviewers, as an example, and you can't publish without them. So, earlier talk, mentioned Git flow. We have individual verbs in our release process that are Git flow verbs, that you have, so you have to follow, you can't push something into production without following that workflow. So then once it's in production, I did this little diagram to kind of show how all the pieces fit together. We have the tech platform here that's still doing the pipeline, that's still pulling data off devices and formatting it properly and putting it in the data lake. And then eventually, once it gets to a component that DSci owns, making an API call into the data science platform. So the tech platform is like a bunch of stuff, but again, still mostly Java. And then the data science platform is, of course, where we do our Python code at this company. And again, because like literally everything here is big data, it's actually mostly PySpark. And we kind of like usually if you look at like a modeling pipeline, they'll use PySpark and they'll do something like they can use MLlib, like Spark has like a bunch of ML tools. But if they want to do something like, suppose, they have something in scikit-learn or they have something in PyTorch or something that they needed to use. Typically what they'll do is they use Spark for the querying, and then they'll drop it into a Python task, the pure Python task. and then they'll do the next component of it using PyTorch, for instance. And then they'll produce the results, and then they'll go back to their Spark cluster and ingest the results back into the data lake. Like that's the typical workflow. But the thing about it is that PySpark, the PyTorch, all that kind of stuff is all owned in production by data science. And then of course, like this Hive S3 is like just representing the data lake. Yeah. And here's an example just to kind of drive the point home of the previous. This is an actual example of one of the models that's running in our platform. So we have like the RPD pipeline, which is part of our audience measurement pipeline. And this audience measurement pipeline has to run daily. The data starts coming in early morning, and then we have to have the results out the door, early, like morning, just regular morning, Eastern time. So this pattern recognition, actually the RPD pipeline is a small part of the audience measurement pipeline. Pattern recognition is a very small part of the RPD pipeline. And all this stuff, hundreds of different components, has to run every single morning and produce a result. And then this is actually what we mean when I talk about like productionalized modeling. This pattern recognition model, which I'll get to what it does in a second, but like you can't have any. Actually, okay, this is what it does. So pattern recognition is a really generic name, but what it does is it looks for evidence, like patterns in the input stream for the RPD measurement. RPD is return path data. Well, that's what it stands. Okay, so return path data is device data that's saying like basically like this device was tuned to this. To this channel at this time, right? Okay, and then pattern recognition says I'm going to look for patterns in this RPD data that indicate faults in the hardware, such that we can actually use that data to for our audience pipeline. So pattern recognition is actually like fault finding recognition. That's the patterns it's trying to match on, is it's looking for faults. Now you could take a bunch of RPD data, give it to data science and say find the bad data in here, right? But that's not productionalized modeling, and that's not something that we could do as part of our measurement pipeline, because that measurement pipeline's a ball rolling down the hill. It started rolling in the early morning and is due in the morning, and if it's not out on time, people sue us, right? If we breach a contract, if they don't like the results, they try to claim that like the results are bad or whatever, then they're disparage us in the media, and our clients are the media. So, we have to get it out on time and correctly, so like this pattern recognition has to work on data that nobody's ever seen before. No human's ever seen before. You can't just say, load in a notebook, figure it out. It's got to run completely unattended and produce the correct results every time. And this is one of hundreds of models that have to run every morning for our measurement pipeline. And this is just the audience measurement business. You go into the other businesses, we have the same thing going on. That's my last slide. Actually, I thought there was one more. I might have screwed this up. Yeah, okay, there we go. I don't know why I didn't show that slide. So this is like basically the technology stack that we're working on. I fibbed a little bit by saying that our platform is Python only. We actually support R and Java and that kind of stuff as well. But our data science team has, like, as an organization, wants to be, almost all on Python. And the reason why is because you have the opportunity to productionalize on Python. Like I said, you don't have it when you look at something like SAS or SPSS or something. We can't say to data scientists, and I think earlier people talked about this as well. You couldn't like throw them into the Java world. It's not fair to them, and the tooling doesn't exist there. Honestly, it's not a particularly good language for data science, right? But in Python, we do have the tooling. We have these great libraries. We have integration with Spark, which is important to us in particular. We have great SDLC tooling built around it. And we also have pretty much, everything we need. Like we have MLflow is integrated in our platform, right? So we can use that to track. Like one of the things you have to think about when it comes to like productionalizing data science modeling and like data science SDLC is that a trained model, if you're doing, for instance, a neural network, trained model object is actually a build artifact, and the inputs to the build artifact are, the code that specifies it, the hyperparameters that the data scientist has selected, and the training set. So, each one of those things we have to maintain as, as a component of, the sort of the universe that went into creating this build artifact. And again, I mentioned earlier that, if we could get sued or disparaged or whatever, if people think our results are wrong. This is something that I think that Nielsen has to deal with, that a lot of companies who are doing data science, maybe internally for their own modeling or what have you, do not, where, our methodology, like we have independent auditors who want us, who review our methodology, because it's really important, and there's a lot of money riding on it, on the numbers that we produce. And we have like very large, powerful organizations who get extremely upset. I think even when we do a good job, sometimes they get upset because they don't like the answers we give them. So, we have to put a lot of effort as a company, as a platform, and as a data science organization into making sure that we can justify absolutely everything we do. So for us, SDLC is like not just a like, oh, is the code clean, or like, is it following best practices? It's like literally like, the types of things that we potentially have to justify, to external auditors, for instance. And that's why we built this platform, honestly. Yep. And, I guess like pulling it home, I don't think we could have built this platform without Python. Like, even though we do support other languages, like Python just has the confluence of the tooling, the ease of use for data scientists, the tooling for SDLC, and also the tooling for like actually operating on large data sets. And also, Python is really useful for us because I'm sitting in the universe where we're just worried about like build artifacts and, Kubernetes clusters, and is it scaling properly and all that kind of stuff. Well, that world is also a world when you look at like Ansible or Fabric or what have you, where, Python plays a big part in that as well. And then it also plays a big part in data science, which is what our users use, or, being the data scientists. So, yep. So that's how we use Python. Obviously we're hiring. We're hiring for both the, for people who know Python, both on the platform side on my team, and also on the data science side. So if any of this, like, hey, I'm gonna like own a model like pattern recognition in production, if that's exciting to you, and you have a data science background, please get in touch. If you're sitting there saying, wow, it'd be really cool to like manage a platform that's running thousands of Kubernetes nodes and like has to deliver results rigorously, all the time, unaided, you can ping me because we have positions as well. So, yep.
Hey, Jordan, thanks for that talk. It was really good. You're doing some very, very much systems at scale for certain. I was wondering, how was the transition there for the data scientists, getting them to own productionalized code? Do they have buy-in to that? Was it like a positive experience, or did it need a little prodding?
So that's an interesting thing. I think like it depends on the perspective of the data scientists, right? A lot of them, like I've had people, and we have people come to us like from banking and that kind of stuff. Actually, I was, where they say, like they love it that they get to work on really nice technology. Where before, like, they were like doing everything in a spreadsheet, for instance, right? Now they love it that they can actually use PyTorch, right? And the fact that like a platform isn't prescriptive when it comes to model selection, because that's not our business, right? They have so much power and control that, and a lot of them like that. You're right. Like for a lot of them, for many of them, they haven't had the experience really of owning something in production. Like they don't, like for instance, I mentioned data you've never seen before, and you have to like kind of think defensively as as somebody who's writing code, or like hitting an SLA, like writing code that hits an SLA consistently, is something that they haven't done before. And the way I like to look at it is like when I started my career, I was working on content management systems, right? And I remember back in the day, you used to have like a webmaster, and the webmaster would take, you'd have the people producing content for the web, and they would produce like a PDF, right? And then the webmaster would translate that PDF into HTML and put it on the web, right? So when I got into computing, like they were trying to transition from that to content management, where they're saying actually the people who own the content should own like whatever's sitting on the web, right? And so if we want to get rid of that webmaster role, well, the content developers had to learn a bunch of stuff about how the web works, right? They had to learn about how things flow, and they had to learn, like the content management systems themselves, right? But then the CMSs had to be good enough to make it easy, and so that's I think that's the same thing we're doing now with productionalization of data science, where it's like data scientists do have to learn some things about how productionalized data science modeling works, and we have to make it easy for them to learn that stuff. So.
Yeah, I mean, it looks like it's really beneficial just in getting rid of that translation layer, right, that you've had previously, where going from the data science team and then to a developer to actually implement it probably cuts down a lot on the cycles of getting that code into production correctly. That's great. And I'm looking to see if we got any other questions from the web, and I see lots of thank yous for Jordan for the talk and claps and awesome platform in the comments. Anybody out there has some questions for Jordan? It looks like a really, really interesting system to work on, though, for sure. And it sounds like there's roles open, so hopefully some people from the community will reach out on that as well. Okay. Looks like we don't have any other questions, so I'm going to put up the raffle one more time and then invite everybody over to the after party at ChiPy.town. Thanks again, Jordan. Great talk this evening. We had a lot of great talks this evening too. Pretty good event, I think, tonight. Thanks.
Yep. Thank you. Mm-hmm. Okay. See ya.
Bye.